Section 9.1, lesson video part 3. This is the final part, and in this part we're going to take a look at determining whether or not a triangle is going to be a right triangle, acute, or obtuse just based on its side length. So here we have a triangle with 10, 11, and 14. And as a reminder, we did have a test earlier in the year. Do 3 sides make a triangle? So I want to mention that real quick to make sure we don't confuse that. One side of a triangle cannot be bigger than the other two combined. So in this case, since 14 is our biggest side length, 14 is smaller than 10 plus 11. Therefore, we have a good triangle. Now, what we're going to do here is testing, once we have a good triangle, do we have a right triangle, an acute, or an obtuse? So using Pythagorean theorem, we know that if it's a right triangle, a squared plus b squared will equal c squared. Well, in this problem, a and b would be the two shorter sides. That's 10 squared plus 11 squared. And I'll now compare that to 14 squared. 10 squared plus 11 squared is 221. 14 squared is 196. Therefore, the a squared plus b squared, is greater than the c squared. So it's not equal. Therefore, right is off the board. Our two options now are acute or obtuse. So in this case, since the 2 are beating the 1, that means that the side lengths are a little bit closer together, which means the angles would be closer together. Therefore, our final answer would be acute. So if we had side lengths 10, 11, and 14, we would have an acute triangle. What's going to happen is you'll do a squared plus b squared, you'll compare it to c squared, and when it's not equal, that's when you'll be kind of stuck at a crossroads. Is this acute or is this obtuse? So here's going to be a way to remember that, at least I think might help you. In the mid-'80s, there was a wrestler, Andre the Giant. This guy was enormous, as you can see the tail of the tape here with Hulk Hogan. This guy was so big that he would routinely wrestle in these matches where he took on 2 regular size wrestlers. And so I want this to be a good analogy for this situation. When the 1, in this case Andre the Giant, is greater than the 2, that is one enormous, huge wrestler. That is an Andre the Giant size wrestler. Well, if one side were to be squared and bigger than the other 2, that means it's got one really big Andre the Giant type side. And think about it. If a triangle has one really big side, what comes with that? One really big angle. And so that will tell us that it's an obtuse. So hopefully that helps when you look at these rules right here. If a squared plus b squared are equal, and it's a right triangle. If the a squared plus b squared is greater than c squared, they're closer together. That's acute. But if that one side, like I have underlined right here, squared, is bigger than the other 2, then that is one really big Andre the Giant type side. That goes with one really big angle. That gives us an obtuse triangle. And the types of problems that you're going to see here are follow-ups as I have below. Taking a look at a triangle and determining whether or not we have an acute, obtuse, or right triangle. So what I'm going to recommend is that you pause the video and that you try these 3 problems right here. Okay, hopefully those went well. Here are our results. We've got a right, and an acute. And just to kind of go over this, in number 1, a squared and b squared would be 15 and 20. You compare that to c squared, 25 squared. They were the same. In number 2, 8 and 15 were your a and your b. 8 squared plus 15 squared, 289. 17 squared, also 289. In number 3, 16 and 21 are your a and b squared. That gives you 697. 24 squared was 576. So the 2 beat the 1. Therefore, we go with the acute. So put all 3 of those videos together, and that gives you a really good idea of what we're trying to do with the Pythagorean theorem in terms of solving for a side length, as well as being able to use it to determine whether or not we have a right, acute, or obtuse triangle.